What was that?
This valve cover loose, Justin? I didn't touch the valve cover. It's oil. Oh, it's coming out. Oh, the dipstick. Oh, the dipstick. Who did that? You're all over that. I didn't take it out, so I forgot to put it in.
What did it make down low?
It did. I was looking for 13.
Hold on.
But it, like I said,
That's the 5,000 pull. That's not
I
good.
know. 5,000.
That's what I started at.
Where's?
Just here. Go to overlay.
I was on overlay.
Go to open.
Open. 13. There we go.
And then take 14, or I mean,
I want to
take
leave them up
12
there.
off.
Oh, see, look at that. It's even yeah,
Yeah,
it's
maybe
way
more torque
happier.
and and didn't really cost it anything.
It didn't
on the
cost
top.
it
top of it,
anything
yeah.
on the top. Yeah, you want that. You want that size.
2 inch.
Yeah, you're right.
Yeah, what did I say?
679.9, right?
So it made peak torque is 507.1.
Mm-hmm.
And then the horsepower was actually
let off.
it was
Well,
carrying.
that's the last number though. That you can't believe that last number.
Fucking rev it to 8,200. Or
That was
8,400.
78. You wanted me to back it down. A little.
Who?
The owner.
Okay, but
Listen,
he's
if
the
it
boss.
wasn't making any more,
He's the boss.
don't run it in.
Well, it was.
That was your big number.
Just so
the
you
last
know,
one.
at 8 before, it was at what 676.
That's 7,800 RPM.
Whatever. Okay.
And I shut it
Okay.
off
Well, fine. I'll go over here to 8. At 8, it was. So 79. At 79, it was 675.
Yeah.
Over here, it
You
was.
gotta go back one. You can't go to that very last number.
Okay, well, I'll go here.
Yeah, it's gonna be right about the same.
Okay, fine.
I mean, you could rev it out, but it's still gonna roll
Look
over
at
the
that
same.
right there. That's
That's-
getting you.
that's
That's
good.
getting you going.
Okay.
Yeah, for sure. And even the horsepower now.
Hey everybody, so no race this weekend, and next weekend's off too, and then we're going to be in Vegas. So I thought I'd do a little video of answering some questions where I didn't need to be at the track or to show parts, because they're more just, conversation. So I just thought I'd read a couple questions, explain it, and get something out to you that's got some racing content, plus a little video of West Side Machine and the little LS we got going on that we helped the guy build, design the heads and all that, and pretty good for pump gas. Anyways, this John Haas, whatever, regarding the rash of engine explosions in the nitro classes and how possibly to reduce them. Some people have suggested numerous solutions such as 1 meg, reduced blower boost, 1 fuel pump, etc. My possible solution is less intake valve lift and possibly less intake valve duration. This change wouldn't cost anything unless I'm forgetting something, as they have to buy a cam anyway. This would put less strain on the valve train, especially valve springs, with less valve opening, less air fuel goes into the engine. Your thoughts, please. Well, my first thought is, well, there's lots of them, but my very first thought is what do you want us to do? We're the quickest things on the planet on pavement, and you want us to slow them down to not blow up as often? I don't see how that's good for the sport. We're there to push things to the envelope as best we can within the rules that NHRA gives us. And if we cut way too far back to try to prevent blow-ups, it's not going to be as entertaining for the crowd, because we'll never see more than 340 miles an hour. I mean, but within this, it's one fuel pump. We only have one fuel pump as it is. It's a big fuel pump and it's 2 stages, but we only run 1 fuel pump. Switching to 1 meg. The reason we run 2 megs is to keep the fuel lit. I don't think you'd be saving parts or have less explosions with 1 megs, because you'd be putting more holes out. So you might not have the spectacular explosions, but you're going to kick more rods. In my opinion, that's just my opinion. I did run some nostalgia stuff, but we're running so much less fuel with the nostalgia. That's how you can get away with 1 meg. Your solution, as far as, less intake valve lift, less valve change. Yes, but valve train stress isn't what's really causing some of the blowups out there. But that would also slow us down significantly and change the whole tune-up and how we get, and that goes to the clutch and everything else. So one of the biggest things I'm going to say to that is trying to find ways so that we don't blow up or oil down the track or whatever. We need to do that without going backwards, in my opinion. So I don't want to see the cars go slower. What I'd like to see is maybe a rule change so we can make some modifications. We're making so much power out of the existing block design. And yeah, we've done small modifications and stuff like that, but they're not like bore spacing and different things like that to make them a lot more robust. We're not allowed to do, as far as I know. Anyways, I would look more of that, of what could we do to make a stronger platform that can handle the power we're throwing out of it. But it's amazing how much more we get out of a 500-inch combination that's been ran for so many years, and how you keep tweaking at it. And some of it's not really about making more power. It's about how we apply it and how they get it down the track, and when they can apply it, which, you know, I can talk in generalities with that stuff. I'm not an expert in the clutch, and I'm not a crew chief, and there's a whole lot going on there that I don't, you know, I understand the mechanics of it, but I'm not going to speak to it in that way. But I'd also look at the rash of explosions in the sport, and sometimes, if you notice, they come more towards the end of the season. It's because stuff's getting wore out, and I also work at a machine shop and do a lot of parts ordering and work with a lot of vendors in my day-to-day job, that you would be surprised at how hard it is to get some certain parts. Billet crankshafts right now, through a couple companies, you're looking at 26 weeks. Now, Top Fuel probably gets priority, and you order enough of them, you get moved up the line. But getting the availability of parts and keeping that part cycle shorter, I should say, is one of the things that will really help prevent, you know, some rash of explosions. So every now and then you get a bad batch of parts. You have some bad events that you have the same gremlin that you can't find. So one team might blow up several times in a row until they sort out a problem that they didn't find or couldn't find or thought they found and didn't. And everybody has that. And then but parts fatigue and wear, and yeah, we cycle parts, but sometimes you got to put stuff in there that you wouldn't be your first choice, but you don't have anything else. And you can't get it. It's not money. It's not available. Not there. You're waiting or not available, and you still got to make runs. So, I see more explosions later into the season just from parts fatigue. And then there's certain things that you guys are not going to hear about because we're not going to come and say, hey, but this guy made this mistake or that mistake. But, you know, the turnaround is fast. There's a lot of work being done on these cars every round. There's a lot of work being done at the track to get stuff ready for the next round. If you've ever visited a racetrack, and if you've ever visited Top Fuel teams, we don't leave our pit much. It's not that we wouldn't like to go watch other racing and stuff like that. We're working all the time. And depending on how much of a part surplus you have, depends on how much more or less you have to work at the track to be ready for the next day or be ready for race day with enough stuff to go 4 rounds if you blew it up every round. With that being said, mistakes happen. So some of these blow-ups are just people have made a mistake, and that's the consequence of it. And that's just part of Top Fuel racing and funny car racing. That's just part of it. It's why it's a team sport, not just a driver. That everybody on that team had to do their job and do their job correctly to get it down the track. So I hope that kind of answers my opinion on some of that stuff. But I wouldn't mean reducing blower boost. We're limited on overdrive now. They could limit that more. But most any of these things at this point that this guy mentioned was going to slow the sport down. And if we're going to make anything to try to help keep these things from blowing up, I don't want to slow it down. I just want to make it more robust. So I would look more to, could we change the platform to be able to take more power and abuse, you know, bigger main webbing, bigger bore spacing blocks so you could have more material to make it more rigid, which would make the heads bigger, which would make them more rigid, have more space for valve train control, which really isn't a huge issue for us. There's things like that, but as it is, I mean, that's racing, and so they say. Another question we got is from Yamaha Mike 99. He's asking, he asked, can you explain proper torquing of bolts and the importance or not? Do you have torque wrenches verified for calibration? Thanks. Most trailers usually have a torque tester in them, so you can put your torque wrench in there, set it at 100 pounds, click it and see if it's sitting at 100 pounds, and you can adjust for the deviation if there is deviation. Most of us use pretty higher quality torque wrenches like a Mac or a Snap-on. So calibrated them, and then so my explanation of proper torquing, and somebody that's a better engineer than myself, actual engineer, I'm not an engineer, might speak to it differently, but I'll speak to it in what I know and what I know from the bottom end. So I have to torque the main caps, and I'm torquing the rods, correct? And then the guys on top, they're torquing the heads, and that's for a clamp load. A little bit different reason for torquing those to their torque spec versus, like, say, the connecting rod. So when we're connecting, or when we're torquing a connecting rod bolt, the engineers that develop the rod and the fastener that goes with that rod, for what the rod can hold for its size, and then the size of the bolt that they run to it, the stretch that we're running that bolt based on the material and the size of the bolt is to get what we call stretch. So, and it's hard to fathom, but we measure stretch when we torque rods at work all the time, comp eliminator motors, pro stock motors, all of that. We check stretch as we're torquing the rod to get the proper rod bolt stretch. It's not the torque spec as much as it is the rod stretch. But when you're in a fast environment, like top fuel in between rounds, and you have to pull the rods out, put a new set in, and torque them, you're not going to check individual stretch on each rod bolt. You're going to figure out what the number is, the pound number, to get you to that proper stretch, or within, you know, a half a thou of it. So, and the reason you're doing that is you're torquing that rod bolt, you're figuring out what the torque spec needs to be, the foot-pounds of torque, to stretch it to what the engineers have deemed that bolt needs to be stretched at. Say that would be, and that's based on material and size. So say that proper rod bolt stretch is 6 thou. So then you're going to figure that out and say with that rod bolt and that, it's 100 foot-pounds of torque to get that rod bolt most of the time with the same lubrication to get it to stretch to 6 thou stretch. What the stretch is doing is so the bolt, as you torque it to 100 pounds, actually stretches. And that stretch is keeping it tight. So if you don't put enough stretch into it, and then in the cycle of load and unload, it can loosen itself. And if you don't put too much stretch in it, you've over complianted it, and it'll go loose because it can't stretch anymore. So the stretch that you're putting into the bolt makes it act not like a shock absorber, but it's keeping it tensioned as the rod tries to come together and the rod tries to come apart. That stretch is holding that bolt tight so it can't work its way loose either way, and holding the cap tight and all of that as well. But if you say you put a real big bolt in it, you torque it to 100 pounds, of course it's going to hold it clamped tight. But say you put a big bolt in it and that at 100 pounds it didn't have any bolt stretch, it would come loose. So you need that stretch in there so it keeps it tight the whole time, if that makes sense. And the same thing with the main caps. You know, they're much higher. So we torque main caps, the inner main caps, the inner bolt row is 170 foot-pounds on this car, and the outers are 85, the helpers. So 170 foot-pounds of torque. It's a large fastener, but we're still stretching it somewhat, and that creates the clamp load to keep the main cap from moving, or as best we can. They still will move a little bit. They'll be fretting in between, but you're stretching that bolt so that it has it can still stretch some more to keep itself tight, but it's stretched enough that it can't just rattle loose. And that's the best way that I can explain why we torque and what you're looking for in the bottom end in rod situations. And I hope that helps people and doesn't confuse people too much, but the torque spec is just to get enough stretch that the bolt stays tight and gives you the clamp load you're looking for. All right, everybody. Appreciate you. Check out these dyno poles on an LS. Hey everybody, so this is a little LS that we helped the guy design. We didn't assemble it, but we did all the machine work, and then it's our head. So this is our head package where we do the CNC and the valve job in that. And then he's got a really good intake, a CID intake. So this is going into a boat, a marathon race boat, but it is running on pump gas. We've got this thing on 91 octane pump gas, and you're not gonna believe what it's making. So it is a stock crank, stock rods, aftermarket piston, put some compression in it, and then our cylinder head with some better valves. But other than that, this is a pretty budget build. As you can see, stock front cover, oil pump, no fancy stuff. This thing's running a hydraulic roller cam with, again, our CNC job. These heads are flowing some air. So, and then we're just running, it's running on a carburetor with MSD ignition control. So I got a timing map over here. Not too creative on the timing map. It's just coming off idle, and then we're bringing it up to 32 degrees. It seemed to be happiest there. We went from 29 all the way to 33 degrees and picked where it made the most. Basically 33 and 32 were almost identical, so we're always going to run with a little bit less timing if we can. I'll come over here and show you the numbers. So see right there, hopefully you can see that. It made 675 at 509 foot-pounds of torque, and it's a real broad torque curve. I know that looks steep, but it's really not, and it's carrying the horsepower really well. On one pole we did make 680. Made a couple tweaks where we made more torque this way, and just a couple horsepower less overall, you'd be faster. So anyways, our cylinder head program seems to be working really well. Pump gas motor making 675 with 500 foot-pounds of torque. I think is pretty impressive. So anyways, hope you're all doing well. Thanks.